Hello viewers, welcome to my channel. If you haven't yet subscribed to my channel, do subscribe and press the bell icon near the subscribe button so that you get the notifications of my latest videos, and do not forget to like and share the video. Today we'll be solving the exercises from this chapter, Light, Reflection and Refraction. It's a chapter of physics. We'll be solving the questions 1 to 6. All the MCQs in this exercise. Okay, so we move on to the first question. The question is, which one of the following materials cannot be used to make a lens? The options are A. Water, B. Glass, C. Plastic, and D. Clay. So which one of this, water, glass, plastic and clay, which one of these materials cannot be used for making a lens? See, water is transparent, glass is also transparent, plastic is transparent, but clay, it is not transparent, which means we cannot see through clay. It is opaque. We cannot see through clay. It is not transparent. Okay, not transparent. While all the other materials are transparent. So therefore the answer is D, clay. Since it is not transparent, clay cannot be used for making a lens. Okay, now we move on to the second question. The question is, the image formed by a concave mirror is observed to be virtual, erect and larger than the object. Where should be the position of the object? So I hope for this you don't even need options. First I will just explain the question, then I'll move on to the option, then to the answer. Here you should be recalling the image formation by concave mirrors. The question is, the image formed by a concave mirror is observed to be virtual, erect and larger than the object. Now recall all the ray diagrams in the image formation by a concave mirror, then you will understand, or then you will remember that in the last diagram we saw, in one of the diagrams we saw that concave mirror forms a virtual and erect image which is larger than the object. So where the the object should be where it was when we learnt about the ray diagrams. We saw that the object was, this is a concave mirror, the object was between the pole and the principal focus, right? So this was our image, this was C, right? I'm just drawing a rough diagram, okay? Then where these two rays met over here, larger than the object, right? Recall this diagram, we have already learnt in our previous videos. So it was between P and F, between pole and principal focus. So we have already found the answer, but we have options. The options are between principal focus and the center of curvature. B option is at the center of curvature. C, beyond the center of curvature. And D, between pole of the mirror and its principal focus. So the answer is D, between pole and principal focus. So these options are just to confuse you. You might get confused between F and C, or between P and F, at C or beyond C. These are just to confuse you. But if you're thorough with the image or with the ray diagrams, then you can blindly tick on this D option. You don't have to go for looking at the options at all. Next, we move on to our third question. Question number 3. Where should an object be placed in front of a convex lens to get a real image of the size of the object? Again, for this question also, you should be recalling the ray diagrams which you studied for convex lenses. Remember, when we studied the ray diagrams related to convex lenses, we saw that optic center, okay, and this is F1, F2, 2F1, 2F2. When our object was somewhere over here, our image, after all drawing all the rays and all, our image was somewhere over here and it was of the same size. Just remember the ray diagram, okay? So where is our object placed? It is placed at 2F1, twice the focal length. Just remember all the ray diagrams and you will be able to recall. The options are at the principal focus, at the principal focus of the lens, at twice the focal length, at infinity between the optical center of the lens and optical center, okay, and the principal focus. So these are the options, okay. So twice 2f1. Twice the focal length means 2f1. That's what we saw. When the object is placed at 2f1, image is formed at 2f2 and the size of the object is equal to size of the image. This is what is a condition, and here it is a real image. The image is also real. So our answer is B, at twice the focal length. See all the conditions, see the lens, see over here is given real image, then size of the object is equal to size of the image. Read the question carefully, remember all the ray diagrams. Your concept should be clear while solving these kind of questions, because you have options over here and options are mainly to confuse you. Then fourth question, a spherical mirror and a thin spherical lens have each a focal length of minus 15 centimeter. The mirror and the lens are likely to be then few options are given. A, both concave, B, both convex, C, mirror is concave and the lens is convex, D, mirror is convex and lens is concave. Very much confusing options, but the answer is very easy once you look at this negative sign. So we know that whenever there is a negative sign, it indicates that it is concave. The focal length of the spherical mirror as well as the spherical lens is minus 15 centimeter. Okay, minus. So the focal length of spherical mirror means concave mirror and concave lens is both negative. So therefore our answer is both concave. The mirror and the lens are concave. Now we move on to the fifth question. Fifth question. The question is, no matter how far you stand from a mirror, your image appears erect. The mirror is likely to be option A, only plane. Option B, only concave. Option C, only convex. And option D, either plane or convex. So we have seen in the whole chapter that plane mirrors always form virtual and erect image. Concave mirrors generally form real and inverted image, but only in one case it forms virtual and erect image. Convex mirrors always form virtual and erect image. But here in option D you see either plane or convex. So both are applicable. Plane mirror and convex mirror always form virtual and erect image. Here the size is not mentioned. If it was, the size is always the same, then it was only plane. But the question is, it appears erect, which means it is also virtual. So put a tick on this option D. It is either plane or convex, because our condition is only virtual and erect. Size is not mentioned. If size was mentioned, it was supposed to be either plane, only this option, or only this option. If the size was like same size, if it was mentioned in the question same size, then your answer was option A. Or if the size was mentioned like the size is always smaller than the object, the image size is always smaller than the object, then your answer was supposed to be C. But here nowhere size is mentioned, only the nature of the image is mentioned. So therefore it is option number D. Then final question, we move on to the sixth question. Which of the following lenses would you prefer while reading small letters found in a dictionary? A convex lens of focal length 50 centimeter, a concave lens of focal length 50 centimeter, a convex lens of focal length 5 centimeter, and D, a concave lens of focal length 5 centimeter. Very much confusing options you have, but your answer is very simple provided your concept is clear. We saw in lenses and in power of lenses that shorter the focal length, higher will be the convergence or the divergence. Okay. Generally, we use convex lenses as magnifying lenses. Okay, magnifying glasses or magnifying lenses, convex lenses. Okay, to magnify. Now we want to read small letters found in a dictionary. Definitely we'll be going for a convex lens. But convex lens, so here it is clear, not concave, again no concave. So we do not need these two options. Now there is a tussle between option A and option C. Either you should go for f equal to 50 centimeter or you should go for f equal to 5 centimeter. Which one will you choose? I told you, shorter the focal length, higher will be the magnification. The image size will be higher if the focal length is smaller. Therefore, we need to magnify the small letters found in a dictionary, right? So, we need option C. We need convex lens of focal length 5 centimeters so that our image size will be even more bigger. So, I hope you've understood all the questions from 1 to 6. If you have any doubt, ask me in the comment section. Or if you want me to make a video from any chapter or from any topic, from any subject, just mention in the comment section.